Hello everyone and welcome back. We're looking at solutions to the January 2022 CXC Mathematics Paper 2, and we are looking at questions 5 to 7 in this video. Question 5 is a statistics question. It begins, the cumulative frequency diagram below shows information about the distance d that each of 120 students walks to school in a particular day. And the first thing we need to do is to look at our curve. It's a cumulative frequency curve, also called a less than curve. And look at our axes here, our vertical axis. You notice that 2 centimeters to 20, which means that here is 10, which means that each of these tiny boxes is 2. Also over here, our x-axis, that 2 centimeters here represents 0.5, which means that 2 tiny boxes will represent 0.1, and 1 tiny box would be 0.05. So those are important to note before we jump into answering our questions. Our first question is, how many students walked at most 1 kilometer to school that day? And so to find our answer, what we're going to be doing is to go to 1 kilometer, draw a straight line or a broken line up to the curve, and read off that number going across. So here we have it, and we would end up with 36. So this is 20, that's 10, that's 30, 2, 4, 6. So that's 36 when you read off that number there. And so that would tell us that 36 students walked at most 1 kilometer on that day. Next, we want to look at some estimates for the median, the lower quartile, and the interquartile range. For that, we need to make our lives easier. Just put in the quarters on the diagram. So we have 120. 120 divided by 4 gives us 30. So each of the 30 points are important for us. So 0, 10, 20, 30. This is the first one. So this would be the quarter way point. At 60, we have the halfway point. And at 90 here, we have the 3/4 way point. And these are important in finding our values. The halfway point is a median. So let's find our median by going to 60 and going across, touch the curve, drop it down. And once you drop it down there, you realize that we're looking at 1, 1.1, 1.2, 1.3. So our median there is 1.3. 1.3. That's our median. The lower quartile is from here at the quarter wave value. It's a halfway point between 0 and the median. It's sometimes called the lower median. And so we just take our line and we go through it and we draw it from here, go across to the curve, touch the curve, drop it down, and we get our value. Notice that here, right now, it's saying 0.9. So that's our lower quartile. And then we want our interquartile range. The interquartile range is equal to Q3 minus Q1. We know our Q1, we just worked it out, but we do not know our Q3. So we need to work out our Q3. So our Q3, we take our line and we go to the 90 and we go across and we drop it down. And once we drop it down here, we realize that we're looking at 1.5 here. So this is going to be 1.55. And so from there, we can do our subtraction. So 1.55 minus 0.9 would give us our interquartile range. And that, as you see, gives us 0.65 That is our interquartile range. All right, 0.65. So we have our answers here. Let's move on. Next, we want to look at a probability question. It says a student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers? This is very important. It's saying walked for more than. Notice it's in bold. Pay attention to it. Now, our curve tells us that at each point, at half a kilometer, this is the number of students who walk at most. At 1 kilometer at most that. But this is saying more than. So let's see what happens at 1.5. At 1.5, here we have passes right there, and we should go across now, and it's telling us that it is 82. So 82 students walked at most 1.5 kilometers. But the question is saying, how many walked for more than 1.5 kilometers? Then those would have to be the other students who are up here, between here. And so what we need to do is to do a subtraction. 120 minus 82, and 120 minus 82 gives us 38. And so now the probability that the student walked for more than 1.5 kilometers would be that number of students, 38, over the total number of students in the thing. That's 120. And we can simplify this a little bit. Always remember that when you're doing probability and you get an answer, if it can be simplified, you should simplify it. We can divide this by 2. We end up with 19 over 60. I'm not sure if CXC still penalizes for this, but probabilities should always be written in their simplest form. And that's something you can easily do on your calculator. Now let's move on to the next part of the question. Here we have a table. Complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. Here we have the midpoints. You know, the midpoints are found by adding the two end values and dividing by 2. So here we have 1.5 plus 2. We divide that by 2. Of course, that would give you 3.5. And 3.5 divided by 2 is 1.75. So we have that value. And now we have to fill in two values over here. We have the frequencies, number of students, 12, 24, 46. We're missing 2. And noticing that we were not given the frequencies at all. We weren't even given the cumulative frequency. We have the cumulative frequency curve. And the cumulative frequency curve is drawn using the cumulative frequency. But we weren't given the individual frequencies. And this table is asking for individual frequencies. So we need to go figure out what this cumulative frequency is from the curve and then come back and fill in these and work it out. So let's do that first. So here we're going to fill in the cumulative frequencies. And starting at 0.5. So we have 0.5, we have 1, we have 1.5, we have 2, and we have 2.5, and then 3. So we need to fill in these cumulative frequencies and then use it to work backwards to find our individual frequencies. All right, so this is the upper boundary, and then we're going to fill in the cumulative frequency here and then find the individual frequencies. All right, so the first one was given in the table. We always start with the first number. The first number is the first frequency there, that's 12. That one will be the same there, and you can verify that from the table. Look here, notice that at 0.5, when you go up to your curve there and touch it, go across, that you're actually seeing 10, 12 there. The next one would be at 1. So we go here and touch our curve, go across, and notice there that we're seeing 36. That's 36 there. So our cumulative frequency here is going to be 36. The next one at 1.5, we had worked out that one before. I think we got 82. Yes, we got 82. Let's just fix that. That's swiveling line. So here, instead of using the straight line, I'm just going to do that. Go across here. All right. And there we had it at 82. So that was 82. And then the other one at 2, of course, we're going to follow this line all the way up here. And this would be our value right here. And then we go across. And that cumulative frequency is telling us that it's 112. And then the next one at 2.5 going all the way up here is 100 and it's right below. So it's 118. And of course, the final one is 120. So we can work backwards from this to find the individual frequencies by subtracting. So 36 take away 12 would give us 24. 82 take away 36 would give us 46. 112 take away 82 would give us 30. So these are individual frequencies. And 118 take away 112 gives us 6. 120 take away 118 gives us 2. And so these would be the individual frequencies that you need, 12, 24, 46. Let's verify on the table. 12, 24, 46, yes. And so our next two numbers would be 30 and 6. 30 and 6. And now what we need to do is some multiplication. These are already done. So 30 times 1.75. That gives us 52.5. Remember to pause the video and verify it for yourself and check it and make sure that you're not just watching the video but actually doing the question along with the video. Then 6 times 2.25 gives us 13.5. That's actually the best way to do it and to use the video as a guide rather than just watching it passively. So here we have our table filled out. And once we have it filled out now, we can simply go ahead and add these. And adding these up, just punching them in your calculator, the sum of all these numbers is 150. Add them up, all of these. And then remember that we're asking for an estimate of the mean. There are 120 students in the sample. So we're going to divide. So our mean is going to be equal to the 150 students divided 150 kilometers divided by 120 students. And that will give us approximately 1.25 kilometers per student. So this will be the estimate. So remember, this is easy to find, but to find individual frequencies, we needed to go and reconstruct the cumulative frequency and then use it to find our individual frequencies. And once we found those, we finish the multiplication, add them up, and divide by 120. So that concludes this question. And let's move on to the other question, number 6. At a track meet, a cylindrical container fitted with a pipe, as shown in the diagram, below is used to serve water to athletes. The cylindrical container has a radius of 12 centimeters. So this is the radius, a height of 20 centimeters. Is completely filled with water and the pipe is fitted at the bottom. So all the water will run out. And and its water is put into cone-shaped cups through that pipe. All right. This cone has a radius of 3 centimeters and there's a height of 8 centimeters. Now, the first thing we want to calculate is the volume of water in the cylindrical container in liters. And we're given a conversion there. So the formula that we use for that is the volume is equal to the area of the base times the height. So the volume here is equal to pi r square h. It's a circle. And so we can easily put in our numbers then. 3.14 times the radius, that's 12 square, times the height, that's 20. And punching those into your calculator gives us 9,043.2 centimeter cube. Since we have 1,000 centimeter cube to a liter, then this is going to be approximately, writing into 2 decimal places, this is going to be approximately 2 decimal places. Well, I had it at 1 decimal place. Punching it to 2 decimal places, 3.14. Let me just do that calculation again. 3.14 times 12 square, that's 144, times 20, actually gives us 9,043.2. So that's what it is. And then we're going to write that to 2 decimal places. So dividing by 1,000, it's 1, 2, 3. We end up with 9.043 liters. All right, so this is our answer in liters. 9.04 liters to 2 decimal places. All right, there we go. 9.04. Okay, fix that. So we have worked out the volume, and now we need to go on to the next part of the question. The next part of the question gives us wants us to find the volume of the cone and use it. So the water flows from the container along the pipe into the cone-shaped cups at a rate of 7.8 milliliters per second. Calculate the time taken to fill one empty cup, and give your answer to the nearest second. So we need to find the volume of this cup first, and then once we see how much water it holds, we can work out the time. So this is our formula here. The volume is 1/3 pi r square height. So 1/3 times 3.14 times the radius square, which is 3 square, times the height of the cone, which is 8. And that gives us a number, 75.36 cm cube, which is the same thing as 75.36 ml. And since the cone holds this amount of water, and water is coming in at a rate of 7.8 milliliters per second, we can do a division by saying 75.36 divided by 7.8. And once we do that division, we end up with approximately 9.66. Please remember to verify, which is approximately 10 seconds to the nearest second. So it will take approximately 10 seconds to fill the cup, the cone-shaped cup. So what we do is that we find the volume, and once we found the volume, we use this to work all the time. And here we have approximately 10 seconds. Moving on now. Determine the number of empty cone-shaped cups that can be completely filled from the cylindrical container. Let's back up a little bit. Remember that when we worked out the volume of this was 9,043.2 ml or cm cube, and the volume of each cup is 75.36 ml or cm cube. So what we need to do to find how many cups can be filled from the tank is simply to do a division. So 9,043.2 divided by 75.36. Once we do that, we get our answer. And that tells us that we can fill approximately, when you do that division, 120 cups. All right, moving on to the next one. The next one is a pattern and sequence question. And here, as usual, we are given a pattern, a figure, the second figure, the third figure. And what we want to do is to create the other figure in the diagram and add more lines of unit length and dots to figure 3 to get figure 4. So notice that here that you add the diamond there and then complete the rest of the octagon. So we're going to add the other piece here like that. And of course, then fill in the rest of it. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it's something like that. And you would have used your ruler and drawn it in, and you would have gotten your shape. All right. So let's move on to the other part of it. Here we have the information from the table collected from that. So the first figure would have 8 dots. And dots, these are the dots on the side, and then has a perimeter of 8. And then the second one will have 16 dots, etc. So 8, 16, 24. We have 2 number sequences working with. And we will need to fill in these. Now notice here that 8, 16, 24. So notice that this is going up by 8. 8, 16, 24. So the next one is just to add 8 to this. And 24 plus 8 gives us 32. And then 8, then 14, then 20. Notice that this one is being a plus 6 each time. So this one here would be 26, which makes sense. Now we take a break and we jump down to these and we have this number here. What many students do in this type of question is that they waste time trying to write these out and figure it out. The better thing to do is to figure out the pattern first. And once you figure out the pattern, you can use it to answer the remaining questions and save time on your exam. So notice in this one that 8 is being added each time. It's a plus 8 each time. 8 plus 8 is 16 plus 8. So we can look at that and say, all right, take that 8 and multiply this figure number. That's one way to do it. Another way to do it is to use formula. I'm not going to use a formula here. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. So notice that what we're doing right here is just saying 8n. And this one we're adding 6. So we take that 6 and multiply this figure number. We end up with 6 times 1 is 6. And then the difference between 6 and 8 is 2. And then 6 times 2 is 12. Difference between 14 and 12 is 2. So we're adding a 2. So here it means that we're going to have 6 times n plus 2. And once you're finished with that, then you can easily answer your questions. So rather than spending time to write out the numbers and to reach at this point, simply go ahead and spend your time finding the formula. And then once you find the formula, you can actually figure that out easy. So 6n plus 2 here equal 86. And we can find the answer there. So 6n is equal to 86. Take away 2. 6n is equal to 84. And then we can say n is equal to 84 divided by 6. And that gives us our answer, the answer that we're looking for, which would be 6 into 8, 1. And 6 into 24 goes 4. So that's 14. So here, the figure number would be 14. And then once we know our figure number, we can find this one because this one is going to be multiplied by 8. So 8 times 14, that's 80 plus 8 fours 32. And that gives us 112. And then we have already solved this part. So we're good with that. Last part of the question says, for any figure with the number greater than 1, the number of dots D is greater than its perimeter, which is true. So notice here 32, 26, 24, 20. So the number of dots is greater than the perimeter. and it says determine the value of n for a figure in which the difference between the dots and the perimeter is 36. So the difference between the dots and the perimeter, this represents the difference between the dots, and this represents the perimeter. So we can say, all right then, 8n, let's put that in a different color. So 8n minus the whatever number this is, minus whatever number this is. When we do that subtraction, we're going to end up with 36. That's pretty much what it's saying, the difference between the dots and the perimeter. So we have to subtract all of this from that, which means we have 8n minus 6n minus 2 gives us 36. We have an equation to work out. This gives us 2n minus 2 equals 36, which means 2n is equal to 38. And therefore n is equal to 38 divided by 2, which is 19. So in the 19th figure, the number of dots is going to be 36 more than the perimeter of the shape. And you could actually go ahead and check that out, but I'm going to leave that for you to do. That's it for this part of it. In our next session, we'll look at questions 8 to 10. We hope that you found it useful. I hope you found it useful. And if you're new to the channel, please remember to subscribe. Thank you for watching and continue working hard.